Hey everybody, Emily here. Great to see everyone. I'm an MIT alum, course 2 and 15, class of 2011. And I think this is the most MIT folks I've seen in one place since my 5-year reunion. So it's awesome to be here. I do all of my work in future mobility and transportation topics. So how goods and people move and how that will change with technology and business models. And I think one of the areas folks have been really excited about for the last 10 plus years, and even more so in the last 5 plus years, is mobility and autonomy. So if you think about how trucks, ride hailing, all those dimensions, how we take out the driver and autonomy, and I think we have one of the best speakers in the space here today, Andrew Clare. Well, let's welcome him to the stage, the CTO of Nuro. So let me read a quick bio for Andrew, and then we'll get into some questions. I think we have a pretty short fireside chat here today, and I think we'll also have some time at the end for questions from the audience, so feel free to use your Slido and add questions. So as I mentioned, Andrew is Nuro's Chief Technology Officer, and he leads the team responsible for the software, design, sourcing, manufacturing, and validation of Nuro's self-driving, zero-occupant on-road vehicles. Prior to Nuro, Andrew was a staff program manager for Tesla's Model X vehicle program, which was awarded the 2016 Golden Steering Wheel, one of the most prestigious automotive awards in Europe. He earned his PhD, master's, and bachelor's in aerospace from MIT, where he was a National Defense Science and Engineering Graduate Fellow, and he is a co-author on 5 technical journal articles and 9 conference papers. So let's welcome Andrew again. And maybe let's just dive into the first question, Andrew. We've seen AI being used for a lot of different transport and mobility applications. Could you explain a little bit about what Nuro does, and why did Nuro make the decisions it does to play in the space it does, and how you got here?
Absolutely. Well, good morning, everybody. It's great to be here today. It's always great to be around a bunch of MIT folks. Having spent almost 10 years of my life at MIT, it's a very special place. Met my wife there. Oh, thank you. I agree with that. Agreed. Met my wife there. We're now raising 2 kids here in the Bay Area. And even just reconnecting with some of my professors. So David Newman, one of my inspirations in the Aero-Astro department back in the day with her work on really innovative spacesuits. Daniela Roos actually taught the robotics course that I took as an undergrad, and then I had the opportunity to serve as a lab assistant in her course as well, and really got me started on my journey in robotics. So just great to be here. And when I think about my journey from MIT now to working at Nuro, and I'll explain a bit more about what Nuro does, we've really been on this transformation in transportation for quite some time now. And we were talking earlier this morning about the journey and the increases and enhancements in machine learning and AI over time. Self-driving is one of those industries that really got its start through the advent of advanced machine learning and computer vision. And so that is really how it all got going, in addition to obviously the improvements in sensors that came about, the advent of active sensors like LiDAR, as well as improvements in compute, right? The fact that we are all carrying around essentially supercomputers in our pocket is one of the things that has enabled this entire industry. And so Nuro, for those of you who aren't aware, it was a company founded about 7 years ago. The mission of Nuro is to better everyday life through robotics. And our founders, when they chose the domain name for the company 7 years ago, chose Nuro.ai, which wasn't as trendy back then. But now, seems a little bit like they were thinking ahead of the curve. And they've always seen that AI applied in the physical world through robotics can really help to better everyday life for people around the world. We have been developing, as our first application, what we call the Nuro driver. This is both the software and hardware that can power an autonomous vehicle and help it drive under all conditions that it needs to within our operational design domain. And we've applied the Nuro driver to 8 different vehicle platforms in the 7-year history of Nuro. We're quite proud of that. It just shows how generalizable this tech has become. But what we've chosen for the very first commercial application of our technology is autonomous goods delivery. And as we saw during the pandemic, all of us want to have things brought to our home preferably in a contactless manner, as affordably as possible. And so we have been working on this problem for quite some time. We have tremendous both commercial and supply-side partnerships to help us scale this. And so we've made some very specific choices that I think differentiate us from others in the autonomous vehicle industry. We've chosen, for example, to build a custom electric vehicle that is specifically tailored for goods delivery. This is a smaller form factor vehicle, about half the width, half the length, half the weight of a typical car. It also is a more affordable vehicle because we don't have to put all of the things in that car that you might have for 5 or 7 people that you're taking around. And it's a fundamentally safer vehicle. When you think about the 40% of daily trips that all of us in this room take that are for going and running errands, the fact that you don't even have to get in your car at all makes it the safest possible trip, right? That this is no person inside of our occupantless vehicle. And that really creates some advantages both from the safety for outside road user, vulnerable road users, where we can take safety technology that for years has been focused on protecting people inside and turn it inside out. We can do things like compliant front ends that are designed for that worst case scenario of having an impact with a pedestrian. We can do things like external airbags that, again, are oriented towards making this the safest possible vehicle.
And actually, continuing on the thread of safety, Andrew, could you talk a little bit about how you think about ensuring safety given how critical it is with an on-road vehicle, especially given the usage of AI in the tech stack?
Yeah, so the Nuro driver is a very AI-first application, right? It is something that for years, as I've said, we have used machine learning and advanced techniques in computer vision across our entire stack. And I'll talk a little bit more about that later, but to your question about safety, this is operating in and around all of us, driving on our roads, walking in our neighborhoods, taking our kids for a walk in our neighborhoods. And so the amount of rigor and discipline that we have to have in both our development process as well as our validation processes to ensure safety is very, very high. We've also decided to take an approach where, while we have the advantages of what machine learning and AI can do inside of our stack, we also put certain more rules-based checks on what the AI creates in order to ensure the safety of what the vehicle chooses to do.
Excellent. And maybe then we go back to your point about the tech stack. If you could explain to us a little bit how that's evolved over time, how AI has influenced the tech stack, especially as technology advancements have occurred over the last 7-10 years.
Yeah, I'll take it sort of in 3 steps. There's the perception stack, how we see the world. There is the behavior stack, how we decide what to do. And there is also the aspect of mapping, how we decide where to go in the world. And we've seen evolution across all 3 of those over the past decade, frankly, with advances in AI. Perception was really where it all started. If you go back to the DARPA Grand Challenges of the mid-2000s, there was both the regular Grand Challenge as well as the Urban Grand Challenge. That was the first time that we were able to apply advanced machine learning techniques in computer vision. And so from the get-go of this industry, our perception stack has really leveraged advanced AI and machine learning. But more recently, Nuro has been evolving our stack from sort of more basic, neural network type assessment of, classification of objects into a more unified perception model that is based on the same kind of foundation models that we see in things like GPT-4. We're using transformer-based architectures to encode the world state, to fuse all of the information from all of our sensors, and to use that in our perception stack trained on billions of data points that we have from our proprietary data set. What you can't do is train this on the internet because you need actual road data. And so we have the advantage of 7 years of road data that we've been collecting that we can use to train these foundation models in perception. And what we've seen is advances in both precision and recall of that perception stack, as well as reductions in latency, and the ability to run this in real time on our vehicles in a very safe manner. Moving to the behavior stack, if you go back to the Grand Challenge days, everything started with very traditional robotics path planning methods, right? And so that is one of the major areas that has evolved as we've started to implement more and more advanced AI and ML. We, for example, have done both a state encoder of the world, which again is a pre-trained, self-supervised large model that we have used as an input into our behavior stack, and then we've fine-tuned different models on top of that for both the prediction of where other agents might be going, as well as decision-making about where our robots should go, using, again, large transformer models that we fine-train through either supervised learning, with humans providing feedback to that model, or reinforcement learning as well. And so these techniques that you see out in things like GPT-4 or diffusion models, they're starting to make their way into the self-driving industry. We're quite proud of what we're able to do there. The final one is about mapping. Traditionally, in the self-driving industry, we've used HD maps. And this works quite well because we can define both the area that we want to operate in, driving from a store to your home and back. But if we're really going to scale to the entire country and eventually globally, we wanted to find a way to reduce the cost of mapping. And so this is also a great place where we've applied ML to, instead of having a HD map that we developed ourselves, we can use as a prior SD, sort of standard definition maps that are readily available, that run on all of our navigation services today. And we can infer features of the road, such as where we want to turn, where curbs are, where different stop signs are, from the perception stack itself. And so this movement from HD maps to inferred maps through the power of AI has allowed us to reduce the cost of mapping between over 10x.
Wow, 10x. I remember when we were looking at this industry 5 years ago, everyone was only thinking HD maps, and that was the only way to go. So that's a big game changer. And actually, speaking of evolutions in technology, we all have been hearing a lot about large language models, Gen AI. Can you share a little bit about how those applications and technology could be used within autonomy?
Yeah, I'm really excited about the potential for large language models in autonomy. I think we have to figure out the right ways to apply them, and we have to figure out how to run them in real time in order for them to be applied on board. But even before we talk about running them on board, there's a tremendous amount of ways that they can be used off board as well. You can imagine they can be used to create new training data, new training sets, also sets that we can use for validation. They can imagine new scenarios that we haven't even experienced in the world yet that we can use for training our Nuro driver on to ensure that it can handle those novel scenarios that we may not have even seen yet. And so plenty of ways to use it off-board. Also plenty of more productivity methods to use, as was mentioned earlier, using it for generating code within our stacks, using it for more efficiency gains within our engineering teams. But the parts that I'm really excited about is what if you could actually begin to use some of the predictive capability of LLMs within our decision-making stack. You could imagine a world, and actually I did this morning. I went to ChatGPT and I said, ChatGPT, I just saw a ball bouncing in the road. Why do you think that is? And it was able to say, well, there may have been a kid who threw that ball. And so that level of starting to get closer and closer to human reasoning would allow us to go from just saying, I see a ball, I should react to it, to why is there a ball there? What preventative measures should I take when I'm thinking about driving that can really enhance the reasoning of our vehicles? The other one that you could do is if you think about edge cases that come with, let's say, human traffic controllers. You have someone who is waving you through. You may even have someone who is talking at you in the case of a police officer. The ability to have natural language interaction, or at least understanding at a closer to human reasoning level of what is going on in these edge cases, will allow our Nuro driver to be even more robust to those edge cases that you could see.
Fantastic. And maybe to move away a little bit from autonomous vehicles and self-driving, what other areas are you excited about in terms of where you can see AI being applied?
Yeah, I've spent all of my career in deep tech applications, and when we were talking this morning in the intro session about all the potential ways that AI can impact the world, I would encourage everybody in the audience to not just go after the productivity applications, not just go after the business applications, but to think about those ones in the make the world a better place applications. And so the three that really get me going are around healthcare, around climate change, and around education. Within healthcare, as was mentioned this morning, using generative AI to accelerate the development of vaccines and drugs for medicine, using generative AI to be a co-pilot for doctors who can have read our entire medical history and help them make the right decisions, that is something that can have massive, massive positive benefits for the world. In climate change, as you all saw from David's presentation this morning, we are facing an immense challenge. Obviously, Nuro is trying to do our part by getting more electric vehicles out on the road. I would love to see more generative AI applications to help in the climate change space, whether through data analysis, whether through design of some of our renewable energy applications, whether through helping with direct air capture of carbon. There's so many possible ways that generative AI can help there. And finally, in education, having something that can literally help you understand the world's entire knowledge and have a conversation piece that you can have with it is something that I think we should be investing a lot more in. So in summary, while I'm excited about the more sort of productivity and business applications, I would love to see more talented folks like the folks in this room get into those more world-impacting applications.
Fantastic. I know we have a few minutes left. Are there Slido questions for us today? Thank you. All right. Here's a question. As more autonomous vehicles start appearing on the roads, how will your data be impacted, and how will your approach to data curation and model training change?
Yeah. So part of the reason that we've gotten very excited about moving to a more AI-first approach is that with more data, our autonomy stack can improve on its own. And so what I think about more vehicles on the road, that produces a positive data flywheel effect. Again, we don't have the benefit of being able to train off of the world's information on the internet. It's not quite enough for what we need for the safety-critical application of driving on roads. But more and more data that can be collected through more autonomous vehicles on roads with the right sensors and compute in those vehicles allow us to really scale the training that we can do of our models. But that alone isn't a limiting factor. You can also think about ways that we can synthetically generate new information, as I mentioned, through generative AI, to create more and more data that can be used for training these models. And that's also why we've taken advantage of foundation models that can be trained on billions of points of data in a self-supervised manner to really enhance the Nuro driver.
Perfect. Maybe two more questions. One is, how do you think public transportation will interact with autonomous mobility in the future?
Yeah, it's a great question. And so, we obviously have gone after the autonomous goods delivery space. Because we think that's where there can be a really great commercial opportunity, but also one that, again, the safest trip is a trip that you never have to take in the first place. When I think about other applications of autonomous technology, obviously there are folks who are working on robotaxis, there are folks who are working on autonomous highway trucking. I think that we're going to have to find a way to work together in terms of public infrastructure and in terms of public transit. That means things like charging infrastructure. We have to think about how all of these autonomous vehicles are going to be charged, especially as we move to electrification. And as we think about the interaction with trains, other infrastructure around airports, as we think about the drop-off and pickup points at these various interaction points between public transit and autonomous vehicles, I think there's room for some reimagination. But on the other hand, we are taking an approach where we don't want to have to impose infrastructure change on the communities and partners that we work with. We want to work within the existing infrastructure in all of the communities that we operate in. Nuro is incredibly proud to be one of the very few companies that are operating driverless today in both the Bay Area and in Houston. And we spend a lot of time working deeply with those communities to help them understand our vehicles, understand how to interact with them, understand the approaches that we've taken to make it safe. And so really making sure that partnership is very deep with both our local, state, and federal officials is important to us.
And beyond partnerships, last question, a lot of talk about technology. There are also a lot of questions, too, about the social impact and both the benefits and the costs, potentially, of removing the driver. Any thoughts on that?
Yeah, absolutely. We've done a number of studies on this, and one thing that we've found is that the kinds of jobs that are here are going to change, and change in a way that can actually create more jobs, as opposed to you having to be driving around in your car to do delivery of goods. There's going to be new jobs that are created in managing these fleets of vehicles, new jobs that are created, obviously, in developing and maintaining this technology. New jobs are going to be created in the equivalent of air traffic control centers that are monitoring all of these vehicles around the world. And so I think of this as taking tasks that today we can actually, through automation, make safer, better, more efficient, and creating new and different jobs that really leverage human reasoning and human knowledge, and that's what we see coming in the future.
Well, fantastic. I know this is a very exciting and dynamic space, and 20 minutes is probably not enough to scratch everybody's itch, but I think we covered a lot of ground, and thank you so much for your insights, Andrew.
Absolutely, thank you.
Big hand for Emily and Andrew. Let them hear it. Big hand. Great job.